Hello and welcome back to the channel Understanding Concepts of Physics. Yesterday we discussed about work done during a thermodynamic process, and today we are going to discuss about heat added during the heat during thermodynamic process. And we are also going to see the assumptions of thermodynamic process. So there are two things which we are going to see in this video: heat added during thermodynamic process, and the second is assumptions of thermodynamic process. Let's see, if the video is long then we'll discuss only one. Now let's begin very quickly, so keep watching. Now the first is heat during a thermodynamic process. So ideally the conclusion of what we are going to discuss in the entire video is in this white sentence, that heat absorbed or released not only depends on the initial and final state, but it also depends on the path. So heat is not only depending on the initial and the final state. We can easily understand that heat depends on the initial and the final state, but it also depends on the path from which the heat is flowing. So let's see. So this is case 1. Let's say there are two states, and what we are supposed to do is we want to go from one system initial volume, some volume is initial, and we want to go to some final volume Vf at a constant temperature. So this is my process. I want to go from initial volume Vi to final volume Vf at a constant temperature. So let's see how we are going to attain this. Now we are going to do this in two ways in case 1 and case 2. So in case 1, I'll just quickly explain this. Okay, let's say if we have a container, and this container is fixed with a massless, frictionless piston. So there is no friction in the walls and the piston, and it's massless, so we are going to consider the mass to be as negligible, and it is initially at some volume Vi, and let's say the temperature is 300 Kelvin, that is some constant temperature 300. I had to take some temperature, so I have taken 300. Now in the state 2, if you see, what we are going to do is we are going to heat this container, and with this heat the piston is going to move up as the temperature would remain same. So we are going to heat it gradually so that the temperature does not change, but because of the increase in pressure, the piston is going to move up, and the piston which was earlier at this location, now the piston has come to this point. So the volume has increased, so initial volume has changed to final volume, and this is happening at a constant temperature. So we have tried to fix the temperature as constant. So if you see, because the volume has changed, as we have discussed in the previous class, that dW is equal to PdV. So because the volume is changed, we can say that there is a change in work done as well. So work is done, work is not zero, work is greater than zero, because the gas has expanded, and definitely the gas has also utilized some energy to increase its some energy has been absorbed. Some energy has been absorbed. So yes, this is what the case is. So we have gone from initial volume to final volume, and that is happening at a constant temperature. So we are doing this is constant temperature. Now we are going to do the same experiment. We are going to go to the same initial volume to the same final volume, even at the constant temperature, by some different method, different path. So let's say we have this case 2. Now in case 2, what we are going to do is, this is your state 1, where we have taken an insulating material, so heat is not able to escape from inside to the outside. No, it is not allowed, and heat is not going to go into from inside to outside, so this is also not allowed. Now there is this insulation which is just a part of the side walls of the container, and there is this wall which is placed at this point, and the initial volume is Vi. The gas is present in this section, so the gas is present only in the below section, and there is nothing in the upper section. So there is nothing here, so there is nothing here. So the entire gas is present in the below section. Now this wall, this wall is a breakable wall, so we are going to break this wall by some means, and as soon as the wall breaks, the gas is going to occupy the entire volume of the container. So now the gas is occupied over here. So if you see, initial volume was Vi and the final volume is Vf. Now, so we are assuming that this initial volume was equal to this volume, this, and we are assuming that this final volume is equal to this part of the final volume. Now, if you see, we have gone from the same initial state to the same final state, and I have because these walls are insulating, there is no escape of heat, there is no intake of heat, so the temperature is remaining constant. So if I am maintaining a temperature of 300 degrees Celsius, 300 Kelvin over here, then 300 Kelvin is maintained over here. So I am going from initial state to final state, that's true, and I am keeping the temperature as constant, the one which I did in the earlier case as well, case 1 as well. But if you see here, there is no exchange of heat, that is Q is 0, and you will see there is no work done as well because there is no piston to be pushed. So you see what has happened here is, okay, we have gone from the same initial state to the same final state, but in that the work done is different. So that's what the statement says. Okay, heat during a thermodynamic process not only depends on the initial and the final state, but it also depends on the path. So if you are taking from the same initial state to same final state, but from different paths, then definitely the amount of heat energy would be different. So in the second case, the heat energy absorbed is 0, but in this case, the heat energy absorbed is non-zero. It's greater than 0. So this is what it is. This is what the statement means. So in case if you are not much inclined towards physics, yes, definitely this is pretty conceptual. In case if you are not inclined towards physics or understanding of physics, then definitely you might feel that okay, this is a bit tricky. But yes, if you go through the video again and again for 2-3 times, you will definitely get it. Also, if you are not inclined towards physics, I would suggest that you remember this statement that heat energy as like work done depends on initial and final as well as on the path as well. So if you remember the last lecture, work done on or by the system not only depends on initial state and final state, but also depends on path. Similar manner, heat also depends on initial and final and the path as well. So this is what it is. I mean, heat during the thermodynamic process depends on the path as well as the initial and the final state. So I hope you might have followed the topic, and yes, we are going to stop at this point. The video is becoming longer. Thank you so much for watching. Subscribe the channel in case you haven't done so, and keep watching the videos in order to follow. Thank you so much. Bye.